Hi. So I'm going to take the fuel types item on our CED document and divide it up. And today I'm just going to look at biomass and coal, at least in this screencast, just biomass and coal. So remember that most of the energy on Earth that we access comes to us from the sun. The sun converts hydrogen into helium, releasing nuclear potential energy, converts into heat, which gets converted to light, which comes streaming to the earth in the form of photons of light energy, right? So that light energy gets absorbed by green plants, either in the oceans or on land. And those plants use photosynthesis to take carbon dioxide and water, which don't have much energy in the bonds between the atoms, and stitch it together to form uh, sucrose, I'm sorry, glucose, and then that glucose can be converted into things like starches and oils and cellulose, plant matter. So the bottom line is, what nature tends to do is it takes light energy and turns this stuff into this stuff, and that has a lot of potential energy in it. So we eat that potential energy and release it, right? So that's what you and I do. We eat things that have sugars or oils or starches, which basically have these carbohydrate molecules in them or lipids, and we breathe in oxygen. And then what we breathe out is carbon dioxide and water, and the energy that was present in these bonds and is not present in these bonds is what fuels our bodies. Well, when we burn wood, we're essentially doing the same thing. So wood is basically cellulose. It's a slightly different chemical structure here, but basically I'm taking this carbohydrate compound and reacting with oxygen, and up your chimney goes carbon dioxide and water, and out of your chimney comes heat energy. So it's the same exact idea. It's just a slightly different chemical reaction. In this case, I use enzymes in my body to catalyze the reaction. And here I'm just using heat to do it. Now, turns out that, as I said in an earlier screencast, in the developing world, they really don't have access to electricity. So most people, in order to cook food and to heat themselves and keep from freezing, they're going to have to just use what we call biomass. They're just going to have to use plant matter to do this, or some other, maybe animal excrement, something that has those carbohydrate molecules in it that they can access the energy from. So collectively, we'll just refer to this as biomass. And what you see is quite stark. If you look at Africa, Southeast Asia, and South America, you can see that a significant amount of the people who live there, their sole way of getting energy for heating and cooking is and heating and cooking rather is from plant matter, right? And as the population, especially in Africa, grows, this is becoming problematic because it takes trees a while to grow. So we find is that the demand for wood is leading to, surprise, surprise, deforestation. It's also causing people to go more into places where they're going to encounter animals, and therefore diseases are going to be transferred to humans. So this is a bad thing, right? And so sometimes people can't even find enough wood to burn, so they end up burning things like animal waste, like dung, or they end up burning garbage, like in India, like all these cities in India. A lot of the problems they have, air quality problems, because people are burning garbage because they're in a poor part of town where they don't have electricity and they don't have access to wood because they're in the middle of a city. So not only does this lead to deforestation, but of course it also leads to human health concerns because we talked about before. In when it comes to indoor air pollution, wood smoke is the big killer. It kills so many people a year. But in the developed world, we do things differently, right? So in the developed world, instead of burning wood for the most part, we're going to burn other things, like what we call fossil fuels. And the main one we use is coal. So again, remember what we're going to do is we're going to take coal, we're going to burn it, we're going to use the heat that's given off, and this chemical potential energy is converted to heat. We're going to use it to, got to check the time, to boil water. That boiled water is going to be then directed over a turbine. That turbine is going to spin a generator and make electricity. Okay, that's how we do it. Now, but the coal, how did the energy end up in the coal? All right, well, coal is basically what's known as a fossil fuel. So coal, and you do need to know this for the test, is derived from terrestrial plants for the most part, that like trees and other plants that died and fell into water, and that water was hypoxic or anoxic. It didn't have a lot of oxygen in it, and it often had fairly low pH, high acidity. And so the aerobic bacteria just weren't available to decompose it. And anaerobes are pretty slow. And so as a result, a lot of the energy that was present in the wood and other plant fibers did not get consumed. It just stayed in the ground. And hundreds of millions of years later, we're releasing it. So we call it a fossil fuel because fossils are basically animals and just organisms that lived a long time ago and got preserved in rocks, and that's what coal is. So basically, you go from a swamp to this stuff we call peat, which is sort of this sort of semi-digested plant matter that then gets compressed to form coal. I'll keep my eye on the time here. Okay, I got 10 minutes left. Now, so one of the things you're expected to know for the test is this progression that happens with these plant matter. So we start off as the plants fall into the water and the water that's low in oxygen and high in acidity, they break apart a little bit, they get semi-digested, and they form this substance called peat, which can be burned. Okay, then with pressure, as the weight of sediments on top squeezes in on it, water gets squeezed off and it becomes a substance called lignite, otherwise known as brown coal. And this is what most of the world has access to. But with continued heat and pressure, like being in the ground, if the tectonic forces can squeeze it, it can get turned into what we call bituminous coal. Won't worry about the sub-bituminous. It gets turned into bituminous coal, and over time into this really good stuff called anthracite. Now, when I say good, it's still it's not good for the environment in terms of what it releases, but it's got a lot more energy in it than these other ones do. A couple things about coal we should know about that are really important in terms of environmental science. First, coal contains sulfur. All right. So remember when we talked about acid rain, it's because of the sulfur that's present in coal. Well, where does this sulfur come from? Well, it turns out that when the plant matter was accumulating, the dead plant matter, uh, the ones in saltwater estuaries, they tend to have a lot of these anaerobic bacteria that tend to contribute a lot of sulfur compounds in their digestive processes. So swamps that are in these saltwater estuaries, which is a lot of the world's coal swamps, they tend to have a fairly high amount of sulfur. Ones that form in purely freshwater ones tend to have a lot less because they have different anaerobes working there. And so for that reason, some of the world's coal is high sulfur and some of it is low sulfur. And it just had to do with the energy of the environment in which it formed. Basically, freshwater, low sulfur, saltwater, high sulfur. Coal also contains mercury. And this is what's causing bioaccumulation in things like tunas and orcas and things like that. It's not a lot, a very small amount, but basically, these are plants. Plants bioaccumulate over the course of their life. So if a tree lived for 200 years, and then, of course, that 200 years, trace amounts of mercury get brought into it, but they don't leave it, then what happens is uh, basically this coal is the accumulation of all the mercury that these trees brought into their systems over the course of their lifetime. And so, because it bioaccumulates, it ends up in the coal. And then when we burn the coal, it gets out of the environment and then it accumulates all over again. Ugh. Now, three kinds of coal you need to know about. Well, four really. We have peat, which really isn't coal yet, okay? But then we have lignite. So lignite is also called brown coal. It has a very low carbon content and a very high water content. A lot of sulfur, a lot of mercury. This is not the good stuff. It's low grade coal. It's cheap, and unfortunately, a lot of countries choose to burn this, especially here in Asia, because there's a lot of it there. Bituminous coal or black coal has been heated and pressed a little bit more. So it has slightly higher carbon content, slightly lower water content. And then we have anthracite coal, which is the one that's had the most heat, the most pressure. It's the quote, the cleanest of it, burns the highest. But no matter what, anytime you burn it, it releases carbon dioxide. Now let's look at the world's coal distribution. And yes, you are expected to know this, okay? So coal is not evenly distributed around the world. And it's important because right now, like 45% of the electricity produced in most countries is coming from it. And if you look, uh, man, it's not evenly, like Africa, South America have very little. Now, you look at this map, it's a little bit deceptive. It turns out, even though from an aerial extent this doesn't look like much, it turns out these deposits here are very, very rich deposits compared to these deposits. And so, in fact, you do need to know this, okay? They always ask a question about this. Who owns the world's coal? Because the world's coal is basically, this is the world's energy source, right? As things are stand right now. That'll change in your lifetime, I hope. All right. So basically, the United States has most of the world's coal, followed by Russia and China, and then Australia. So basically, they'll ask you questions to the effect of which countries have the most. And if you just remember, United States, Russia, China. Let's face it; those are three of the big players politically. Also, all right. Why is that? Well, because they have a lot of the world's energy reserves. Uh, uh, but that's not the only reason. But that's one of the reasons. I think that's the whole thing. Oh yeah. Okay. It is worth noting this. Okay. Coal is non-renewable, right? It took millions of years to make. We're not getting any more of it. And so think about this for a second. it has to run out. If we're not making any more of it and we keep using it, it has to run out. People, they know it in their minds, but they don't believe it in their hearts. And this is a problem. So even forget global warming for a second. Think about this. If the way we make our lights turn on is by burning coal, guess what? In 70 to 100 years, it's gone. And I know that seems like a long time to people your age, but the truth is, like, I'm getting close to this age here. All right. Uh, this is not that much time, guys. This is a human lifetime. And if we run out of it without having a backup plan, we're really screwed. So we've got to come up with something apart from protecting the environment from global warming. We've got to come up with something because we rely on electricity and we get that electricity mostly from coal. And if we run out of coal without having something else to use, we got no society anymore. And that's not going to be good. Hey, thanks for watching. Let me try to turn this off. I'm not sure what I do here. Here we go. I do this every time. I talk to myself at the end every time, like I am right now. I'm so frustrated with myself.